And as I mentioned at the end of that last video, we can look over here and we start to see a pattern over here, and we can implement that pattern using something that I'm going to call a bind function right here. So what you could do with that one is say, I want to get the result out of the f function just like that before. I'm not going to worry about the two tuple values right here. I will assume that these are tuple values here, and they're going to be an int and a string just like before. But I'm not going to declare the two tuple values here, because what I want to do is take that complete tuple result right there and pass it into a bind function. So then I want to pass in g, which is going to be my next value, with the entire tuple from f, the entire tuple result from f right there. And that'll give me the g result, the complete tuple right there. And then I want to call bind again. And in this case, I'm going to have an h function as well. So I'm going to pass g result into there. And as you can see down here, that g result again is going to be a 2-element tuple. And then h result is going to have the complete result in it right there. And I just described that, but let me see if there's anything else I need to do here. So we have fg and h, the bodies of the functions don't matter, and they have the same type signatures we were looking at before. Each function takes an int parameter, as shown here, and each function returns a 2-element tuple, as shown in this area right here. So each function is going to return a 2-element tuple that it has this type of int and string. And as I mentioned, I want to write a bind function that works like this right here. So give me just a few moments and I'm going to change the setup over here. Okay, I have the setup work done over in this area right here. So now if I come back over here, one thing I do note over here is that if you feel like you know what to do, if you feel like you know how to create bind, then don't look down here at all. Don't look there. Go ahead and turn off this video and work on this by yourself. And the goal here is that you want to create some type of bind function over here. So you want to create bind function. It's going to have something here. It's going to have a value here and then a body over there. And then we want to use that like it's shown right here. So let's see if I can copy and paste those guys right there and save that. Again, if you're going to step away, that's what you want to do is implement a bind function. So that will work like that. You'll have these values right here. And you'll also want to have a print line statement of some sort right here. So that's also going to be a to-do item there. So if you're turning off the video, this would be a great time to turn it off. Otherwise, we're going to start working on creating bind. Okay, so if you're still with me, we're going to work on solving this problem right here. So if we look at the code, we want to implement bind. That's what I want to do right now. So this is an example of how bind is used. And you can see the first parameter is going to be g or h. And g and h are functions. So you could see, I think what I'm going to do is make that a little bit bigger because this is going to be a larger type signature. So g and h are both functions that take an int parameter and they transform that into an int and a string tuple right there. So what I'm going to do is I'm going to call that a function because it is a function. I'll use the name fun. As you see right here in h, it takes an int. So that's the int parameter. And then it's going to transform that into an int and a string. So I'm going over this quickly, but I'm assuming that you've watched the previous videos that I've done. But very quickly, bind is taking in a function input parameter right here, g, or in this case, h. And both of those have the same type signature. They take an int and then transform that int into a 2-element tuple. So that is what I've just described right here. This is the description of a function that takes an int and transforms it into that same 2-element tuple. So that is the first input parameter. That covers that one right there. Now the second input parameter is going to be an fResult or a gResult. So if we look at f, you can see that what comes out of f is that 2-element tuple right there. So I will copy that. And now this is going to be our second input parameter. And we can call that one tup for tuple. And that's going to be an int to a string. Okay, so far so good. And now all we need is a return type for bind right there. So if you look at bind, it is returning a gResult. I'm not showing the types over here, and I'm doing that somewhat intentionally, kind of keep us guessing a little bit. But what we could see is that bind returns a gResult, and then that gResult is used right here. Now, a really interesting thing that solves the problem for us is that gResult must have the same type as fResult, which is used right here. So fResult comes out of this function right here. It comes out of the f function. So whatever f is returning is being used right here and here, and therefore whatever gResult is must match the same type as fResult. So again, fResult is a tuple right there, a two-element tuple. So now we can say that bind is going to return that two-element tuple right there. So that's how you solve problems like this, is you just kind of work through the types. And as a brief aside, or as a brief note, this is actually how you solve functional problems all the time, is you look at situations like this and then you derive this kind of information. We create the type signature right here before we try to do anything with the body right there, because now we know exactly what we're getting in right here and exactly what needs to come out right there. And now for the body of bind over here, if you think about it, all it needs to do is automate the process that we were using in the previous video. Okay, so if we look over here, this is what we were doing in that previous video. So as we think about this body, we're going to want to implement something like what we did before. So these were several examples in a row there. And really what we want to do, I believe, is pretty much like these two lines right here. So if I do that, copy and paste that over there, this is the sort of thing we're trying to work with right here. I'm going to work over on this right side first. So now where I have h of int over here, that's the int that we're receiving. So that int is actually that guy right there. It's the first element in the tuple that we're receiving. So that's going to be tup 0 in Scala 3. That's the way we work with that. Now the rest of this line is wrong. So we need to fix that. And I, in this example over here, was the function that I was calling. And so the function that we're calling over here is called fun. So we replace that I with fun right there. And I should mention, if you want to cheat and look at the code over here, you are welcome to do that. And what I'm trying to do is be consistent with that. So then these other two values right here, this one is going to be the int result, and then this one is going to be the string result, coming from the application of that function to that integer right there. So what I do in the book, which I kind of like here, is I could say that the integer that we're given is equal to tup of 0, if you find that hard to read. So we could say that's the given int right there. And then also the given string is going to be tup1. And now we want to work with that right here. So we're trying to create this log message. So we're going to create the log message from the string that we're given right here. And I just said that was tup1. So that's our given string right there. And then we're going to add the string result right there. So now this is our complete log message. We have the string we were given as input and the string result that we just got from this line right here. And now all we have to do is return our two-element tuple as described right here. So then our int result is that, int result, of course. And then the string is our log message. And that should be our bind function. Unless I made any mistakes somewhere, that should be our complete bind function. And as I note in the book, this is a combination of our new int and new string. And one more thing I want to add before I leave here is that you can shorten up this body, and you could probably shorten it down to 1 or 2 lines. I'm doing things to make this more readable here and here. But if you want, as I show in the book, I believe on the next page, you can actually shorten the bind function down to these values right here. So you get the int result and the string result from applying the function to the first tuple value. That gives you that. And then you return the int result, and then you return tuple 2, which came as input, plus your new string result right there. So you can get that code down to 2 lines right there. And now all I want to do over here is go ahead and print our results right here. So we can say result. And then this is going to be $. And what do we want? We want hResult. And hResult comes from bind. So we know it's a 2-element tuple right there. So we would take the first element. This is the way you would do that in Scala 3. That's the first element. And then this will be the second element right there. And that's going to be the debug information right there. So if I haven't made any mistakes, we'll save that and see what we get. And there we go. So you can see that we're printing out the result is 2400, and then the debug information is actually multiple lines right here, multiple lines of output from fResult, gResult, and then hResult right there. So if I were to format that differently, we could do that like a \n right there and save that. You'll see now debug comes down on a separate line. So what I'm trying to stress or emphasize is that these 3 lines are the debug output that comes from right here. And as I come back up here, the only other thing I was thinking I might change that. I kind of like changing that to new int and new string. So then that's the new string there. And then that would be the new int right here, like that, and save that. As I look at this, I prefer those names at the moment, and then I can get rid of that comment right there. And we might also call this one the complete log message, or something to that effect that indicates that this is an accumulator, basically. We're accumulating the given string, and then we're appending the new string to that right there. So in terms of terminology, I prefer those words a little bit better there. So if you haven't worked with higher order functions before, I hope all of that is helpful. But really what I'm trying to do is focus on this process of binding 2 functions together wherever these 2 functions have a mismatch. And again, that mismatch is that this function here is returning a 2-element tuple, and this function expects only an int. So you have to do something to match this output to this input. And again, we call this process binding. This is a bind function that works for this particular situation. And then as I've shown, we get the answer or the result that we wanted right here by applying f and g and h in order. And we also get this debug or log information at the same time, which of course is shown down here. So if I go back to the book, I asked the question, what can we say about bind at this point? And of course, those are things that I just said. It's a useful and kind of cool application of using a higher order function. It gives us a way to bind or glue the functions f, g, and h together so that we can do this. And it's simpler and less error prone than the code that I was showing right over here, where we had to do all this manually and hopefully not make any errors. So that is what bind does for us. And now I hope this is already going off in your mind, but if there's a bad thing to say about bind, it looks like it's dying to be used inside of a for expression right here. That code right here looks like, gosh, if I could write that code like this, man, we would be in good shape. That's a lot easier to read and use than even this code right here. So you think, well, wouldn't that be cool if we could use that in a for expression?